Hello and welcome to Apache TinkerPop's home here on Twitch. Today we have another TinkerPop Wide stream where we explore the wider TinkerPop community, looking at tools, libraries, or graph systems built on the TinkerPop framework, or even applications built on those foundations. Today we have Wemo from PuppyGraph. It's a comprehensive graph engine that integrates seamlessly with your existing tables such as Iceberg, Hive, Hudi, Delta Lake, MySQL, PostgreSQL. I mean, the list kind of goes on. PuppyGraph's query engine allows you to query the same data set as a graph with Gremlin without additional ETL processes or duplicating data storage and processing. So Wemo, thank you for being here today. I think we're all excited to hear about the kind of the latest TinkerPop implementation that we know about.
Yeah, thank you, Steven. It's a big honor for us to share our product with the TinkerTop community, since we have been actually using TinkerTop for quite a while, but it's first time to formally join the community. It's a big honor for us.
Oh, that's great. Well, we're very happy to have you here. I'm sure there'll be lots of questions, but I do have to start. I told you I would start when we spoke yesterday. I told you I would start with just one question, and that is how did you come up with the kind of the best name for a graph that I've heard of in a while is with PuppyGraph. Where did that name come from?
One reason is that some member of the founding team have puppy. And then they like it very much. Another reason is that usually I think the graph haven't been so widely used in all the areas because sometimes it's kind of heavy to use it. The pre-work, the user need to have some pre-work until they try the first query. So we think Puppy is sounds like a lighted product like DuckDB or something else.
Oh, I see. Gotcha.
And the most important reason is that the domain name PuppyGraph.com is only $3. Yeah, yeah, that's why we directly take it. Yeah.
Yeah, well, it looks like we definitely have some support from the Twitch chat. Such a great name. That is constantly the feedback that I hear is that everyone really likes the name. So with that, I will kind of give you some space here and let you get into your presentation. We'll get your screen up here, and yeah, I'll hand it over to you.
Cool. Thank you. Yeah. We call us PuppyGraph, graph analytic engine for all your data. So we are not another graph database. The difference is kind of like Presto Trino comparing with other graph SQL database like MySQL. First, let's introduce our team. I was at a Google F1 team. It's a unified SQL query engine inside Google, and it supports almost all the data source and the data format inside Google. And there is more than billion SQL query per day. You can use a single SQL query to query all the data source, and the different data source can be joined as tables. And then this inspired me to, I think it can even benefit graph more, since users usually have a lot of data and they want to use the graph query language to query it. So we want to have a simple tool to let them run the query in less than 10 minutes. And before that, I was a research scientist at the TinkerPop. I'm also working on the graph query language and also the graph query engine. But to be honestly, I trying to recommend the leadership that we should just implement Gremlin instead of invented a graph query language by ourselves. Dan Feng was my roommate at in college, and he worked at LinkedIn for 9 years and working for the Java service. And Lei was at Instacart and Google. He lived next door when we were in college. And what I need to highlight is that he ranked 6th in the Google Code Jam World Finals. And what we are doing is that first we think the data lake will be the center of the data analytic infrastructure. But at the same time, the user have a lot of other data like in SQL database like MySQL, PostgreSQL, or maybe in data warehouse like Redshift and BigQuery. And our mission is we want to be the Trino, Presto, or Spark of Graph. So the user can use us as an engine to support the graph query language, and all the data other place can be queried by us. And we can also write the result back to other data source. So the user can use the SQL and the graph query language like Gremlin at the same time. Instead of after loading it to graph database, they cannot use SQL anymore. But if in SQL database, it's hard to achieve some goals like graph traverse. So we want to take advantage of a different query language best features at the same time in a single data pipeline. And what the main value proposition is that the people can get rid of the heavy ETL jobs and the data duplication, since most of the company have a super large size of data, and is unrealistic to load them into some other data source and maintain another data stack. And we see that the graph database have 3 pinpoints when the user trying to use them to do the graph analytic, like scalability, performance, and data ingestion. Sometimes user need to spend a week even more to load their entire dataset into graph database. But actually, it's not the fault of graph database, since usually user want to use MySQL to do data analysis, since it's keep the ground truth, and it's the daily operations are there. But in the SQL world, actually we load the data to some other place to do the data analysis. So we're leveraging the other data source like a data lake. So there is no limitation on data set anymore, since because the data lake itself is very scalable, and our engine is also distributed. And with more compute node, we can make it faster and avoid the case of out of memory. So we can have a low latency for complex query. Of course, we don't need the data ingestion anymore. When I was at Google, I saw some trend like the database, the use case of a database and the data warehouse or lakehouse is very separated. But in the graph world, is not happen based on my knowledge, since the user want to use a single product to do the update and the complex query in the same product. And the reality is that a lot of users in the data area will choose SQL database as their ground truth. But this doesn't mean graph is not useful for them. This user also see the value in graph data analysis. Actually, they need a graph data warehouse or lakehouse. But I don't think they have a very good solution today. And the user have to load the SQL database data or even data warehouse or lakehouse data into a graph database and then run graph analysis, which will be very painful, since there will be 2 data stack, and each of them needs the same onboarding cost and maintain cost. Why graph? I think everyone in the community is very familiar with them, with it, and all you guys are experts. So I think I can skip this part, like different feature, different use cases require different models, and there are some data nature to your graph, like this: fraud detection, cybersecurity, blockchain. And let's see what's the advantage of our solution. First, it's fast and scalable. We tried 10 hop neighbors on large data set. It works well because first the data is sharded and distributed on different machines, and can put it all in S3 or some other typical classic storage. And then we can have multiple compute nodes to run a single query. For example, if the query is a PageRank, if it's a single thread, single machine engine, it's hard to achieve that, and it's all easy to out of memory. So our engine is also distributed and leverage some technology like multi-thread processing, and also vectorize the evaluating and something like that to make it the complex query can be returned in low latency. And we also support different data source. Like Steven mentioned that we support a database like MySQL and PostgreSQL, and the data lake like Hive, Iceberg, Hudi, and the Delta Lake. We also support data warehouse like BigQuery and Redshift. Recently, we also support DuckDB. Make it user easier to use. Someone is very familiar with SQL, they can use SQL to prepare the data, and then you only use our engine to run their graph traverse related query. And we support Gremlin and also Cypher as a query language. For the open lakehouse architecture, the advantage is that the user no longer need to maintain separate data pipeline. One single data pipeline, one data source, like the bus of the computer. And before we have a bus, each device need to talk with each other. Currently in the data pipeline is the ETL. But if we have a bus like data lake, and then all the engine and the data tools can talk with the data lake, read from data lake and write to data lake. And then we can use, and then others output can be our input, and our output can be others input, which will be very easy. Even if there is no data lake, if user don't have a data lake, their data already in PostgreSQL or BigQuery, we can also take it as a data source, and then use JDBC catalog to connect with them and fetch the data and push the filter and fetch the necessary data only. After that, we will do all the computation on our side to have a fast response time. Lakehouse architecture, they have a lot of advantage, and it's driven by different big company. And this we want to take the trend of it, make it even easier to handle super large data set, especially for the graph use case when it's hard to load into some other graph tools. And this is our architecture. And for example, if we use the standard Gremlin client connected to the Gremlin server, and then generate a logical plan. After that, for different type of storage, we generate a different physical plan and a different execution node. After one single Gremlin query can query multiple data sources at the same time without ETL. And this is we propose another architecture. Before that, if user want to run graph query, they may need to load data from data lake to graph database. But for us, they can just put all the things in data lake and then use SQL query engine to answer the SQL query, use graph query engine to answer the graph query. But recently, we also extend this into data warehouse and also database like MySQL and PostgreSQL. This is a picture we borrowed from Databricks, like data lakehouse. We want to be on, we want to be here and collaborate with other tools like BI reports with same copy of data. Without PuppyGraph, we need to have a lot of ETL, and with PuppyGraph, it's quite easy. Only one time data loading to the data lake is enough. And this is the understanding, my understanding of the so-called modern data stack. And transactional data system loading data to data lake, streaming system put data into data lake as well. And then there are a bunch of tools around this ecosystem. We want to be this part, like graph analytic engine. And we already published our product at AWS Marketplace. And we also have a free Docker. You can click the puppygraph.com, and then the Docker is totally free. You can build whatever innovation project with your current data and the Gremlin query language. This is how we connect to the data source. Here we take Iceberg as an example. We assume the data is here, and the Hive metastore is here. First, we use Spark SQL to create data into Iceberg. We have person table and referral table. And the schema is like ID, age, and name. And for the referral table is a VE, V1 refer V2. And then all the user need to prepare is a JSON file. And the first part is catalogs. It's a list of catalog include different data source with different credentials. And then we will have a list of vertices, and it's mapping to the tables here, to mapping to a person, and then include a subset of the attribute you want to query. And for edge of lists, it's very similar. The only difference is that we need to point out which column is from and which column is to. After that, you will have a logical graph schema, and it's mapping to the tables. We can directly use Gremlin to query this copy of data. Steven, I think you muted.
The slides, sorry, I'm interrupting for just a second. The slides looked they're a little blurry. I thought it was me for a minute, but then Kelvin said something in the chat, and I
let me.
I don't know if it's just me, and then I was like, oh, it's not just me.
Oh, now it's better.
Oh, that was a little sharper before. Let me see if can we get any feedback from the chat? Is anything we're doing here making it look better? That actually looks a little better to me. Thumbs up from anybody in the chat. Okay, we're seeing sharper now. All right, we're getting good feedback. All right.
Okay, cool. Sorry, I think before that the window is kind of small. Now I make it larger.
Okay, I think we got it.
And this is a benchmark. A common question is that since we don't load data, sometimes the query performance should be bad. But based on what we are doing, based on our benchmark, but it's an informal benchmark we do in a very quickly way. And since for the complex query like 3-hop neighbors on Twitter dataset, since data density is high, it's easy to meet the hub node. So our performance is quite well since the bottleneck is no longer the disk I/O. It's actually the computation. And at the same time, since column-based storage, this is based on Iceberg. And also, since it's a column-based, actually usually will be better for the analytical workload, since the row-based database is better for insert data and update or delete data. And for the complex query, usually the column-based storage is better. And this is some feedback from our user. One is the column-based, they said it's fast and smooth. And also another company called Clarivate, their feedback is fast and stable. Then let's jump to the demo. Oh, before that, any question about it?
I don't see any in the chat just yet. I think people are just consuming what you're putting out there. So yeah, I think yeah, it'd be cool to see what the demo looks like.
Yeah. Can you see my screen?
Yeah, I will put that up there. You do have one question. Why don't we take that one now? It looks like an easy one. Let's do get it up here for us. Got one here about what version of Gremlin are you supporting right now?
We're trying to support the latest one, since if there is an update, we always, but maybe it's not that updated. We are trying to test the latest one internally.
Okay. I think I thought I saw it was a 3.6 something, so I thought you were on the 3.6 line when I was poking around. But so you're probably working on 3.7, I guess, at this point.
Yeah. Since once Gremlin release a new version, we will have some internal test if it passed all the test case. And once we have confidence in that, we will release to make it compatible with the latest one.
Okay, thanks.
Let's start the demo. We have two tables. On right side is the person. They have first name, last name, email, and birthday. We also have a table called person knows person. Actually, it's two tables, but logically it's a graph. So we start our Docker, and then the service is running. And on left side is the JSON file I mentioned. We tell the PuppyGraph where is the data. Like is in api.tabular.io. Tabular is a company created by the co-creators of Iceberg. And we select a subset of the attributes into the logical graph, like first name, last name.
Could you make your schema maybe a little bigger?
Okay, sure.
Just so folks can see what the syntax looks like a little bit. Just increase your font, or I think that might help with some of the. Let's see, maybe a little more.
Yeah, and for nodes, we mapping the from, point out the from is the from column, and to is the to column, and also include the creation date attributes. After that, we can upload the schema. And it will check the whether the logical graph schema is valid, and also check is mapped the tables schema is mapped to are correct. And we can see that the catalog, the vertices and the edges here.
I'm sorry, did your schema, if I can go back to your schema file, did that define, I guess the schema file that you uploaded, that defined also the data types and all that sort of thing?
Yeah.
Okay.
Let's here. Like this type is a data type, and
oh, I see it now.
And for others, like last name, first name are string. And,
yeah, maybe if you could just take a second, just to we talk a lot about like schema lately. Maybe could you just like maybe highlight that all the text in that file and just increase the font on it so we could just see it a little bit more clearly for folks. I don't think anyone can really see it as well as they want.
Like this. The first name is string, and on right side, the first name is also string in tables.
Yeah. Right. Okay.
Yeah. And,
so okay. What data types does PuppyGraph support? Is it supporting pretty much anything that's the native data is supporting, or is there a set group of types that that PuppyGraph deals with?
Yeah, we have some dual-term intersection of MySQL and Postgres data type, and also with the Gremlin data type. And we're trying to mapping the data type as well, like a string mapping to string, and data time mapping to timestamp TZ, like the right side.
Yep. Yeah. Got it. Okay.
And after that, let's see. We can use the graph browser to visualize the tables as a graph here. Zoom in, zoom out. Also check the neighbors and check the attributes. Yeah. And
how large a visual is it? How large a graph can you typically visualize in that visualizer?
This is quite a simple UI we implemented. So it cannot support several thousand, I think. But we haven't tried larger data sets.
I'm sorry, I always have to ask the question.
Yeah. Since actually we recommend the third-party visualization tool instead of our own, if the user seriously want to have some UI, and it's in the later part of the demo.
Right. No, I usually know the answer to that. I always just ask in case I'm completely surprised. But yeah, you got some support from Arthur from G.V just now in the chat. He told me it's not. He said it's not about size, Stephen. So
and then let's we directly jump into the G.V part. Here is the G.V, and you can put the host name into the PuppyGraph server and choose the default Gremlin server. And here is the graph binary v1. And then we can connect it. First, randomly pick up 25 nodes and have a visualization. And also run pick some edges. Let's I think we randomly pick up 500 here.
Nice.
And also check the attributes.
Yeah, very nice.
Yeah, and I think after have some more improvement the compatibility with us, and have more feature about PuppyGraph. I saw it in the recently released note of G.V.
Yeah, cool.
And we can also try some more complicated query, like for hops. And then we want to find how many paths for the for hops from all the nodes. And we can see that there are 20 million passes, and it can be returned in less than 300 milliseconds.
That is that's pretty fast.
And let's see. Then we can jump back to the Gremlin console part here. We use the standard Gremlin console, and the user can try some query like G.V, and also value map. And let's jump into some others like let's see, jump into some other query like 3 hops. And we have 579. We can also find some let's pick 10 paths for the 4 hops. Yeah, this is something like that. And let's see, we also support the Graph notebook. Thanks for the Amazon Neptune guys. Since, yeah, it's open source and easy to integrate. I'm not sure if Steven, you working on this project or.
I mean, it is an Amazon open source project. It is pretty much kind of managed by the Neptune team, and yeah, works with a lot of people. I don't know that everyone realizes we've talked about it, but I don't know if everyone realizes that it's something that can be used with really any TinkerPop enabled database. It really isn't just something for Neptune. So I'm glad you found that and have started to leverage that. Yeah, was there anything special you need to do to get that to work?
I think it almost drop-in replacement. Since it already supports some Graph database, and we just try to directly run on top of a PuppyGraph, and it works. We can use Jupyter to run Python embedded Gremlin query, and then get the result and also visualize the result. It's very easy to use.
I mean, it really looks like you've hooked into pretty much the entire community of tools that sort of TinkerPop enables, everything from the console to G.V to the notebook. I mean, you're hitting all the spots. If I assume all the drivers connect and do their thing. So yeah, it sounds like you have all the stuff there. It's really cool.
Yeah, actually, that's what I wanted to do when I was in TinkerPop, but it seems they build everything by themselves. So
yeah.
But now my friend and I can make the decision, so definitely we want to.
Right. Okay. Well, good. There's a question from the chat here from Cole. He's one of our contributors in TinkerPop. He says, in the logical graph with PuppyGraph presents to users, can a single edge connect vertices from 2 different data sources, or is each data source presented as isolated components in the overall graph?
We can take a single edge connected to vertices came from 2 different data sources. Like one is from example, maybe a node called person, another type of node called software, and the edge will be person created software, and the person can be in MySQL, and software can be in Iceberg, and then there will be and the vertex table itself can be edge table as well. For example, if a software, and then there is a column called author, is of course the type is person, and then there are some other attributes. This table can be software since it have attributes, and also we can map an edge on top of it called person created software, or software created by author. And the edge table can be either in PostgreSQL or in Iceberg as well. So we are trying to make the user don't do ETL. And if the table format is super complicated, the user can create a view on their existing resource. And then we can map the nodes edges to the view. The view can be, if the view can be materialized view or logical view.
Wow. Yeah. Okay, yeah, that's really cool. That's really cool. And we're kind of seeing that. Yeah, that's really neat. Let's see. Are there any other questions dropped in here? Looks like Arthur is asking about other possible data sources. I mean, you have a pretty long list. Are there others that you're kind of looking at?
I think we are trying to also build a Snowflake native app. Since I met the lead developer advocate, and I talked with him, and he said that if it's a Snowflake native app, it can help can save a lot of work on the authentication or other works. Yeah, but then the thing will be the user cannot query Snowflake and other data source at the same time. But that's so we still have planning on it. Yeah, and also most data source support JDBC. We can support. We have a high probability to support it, but haven't been verified each one. Since we will sometimes the final step of the logical physical plan, we will put the filter into the execution node and only fetch the necessary data. If the data source cannot expose their storage layer to us, we can only issue a small select attributes from table query into other data source. So it will kind of affect the performance.
I see.
Since it's become sometimes it's role based and not very good at the complex query. Yeah, so there is a trade-off. But we also have some internal indexing and caching strategy to make it faster. It's based on the user requirement and whether they want to have the latest version of the data or they want to have a super low latency response time.
Cool. Let me see. I mean, I had a few questions. Maybe they'll give some folks time to ask some other ones. I thought I saw somewhere in the PuppyGraph website that there was open Cipher support. Is that there too?
Yeah. Since we want to, based on our organization, software engineer prefer Gremlin, while data scientists prefer OpenCipher. Yeah, and but there is a little weird thing that the Cipher supported by Neo4j is kind of different than OpenCipher. So even we're trying to compatible with OpenCipher, sometimes it cannot be a drop-in replacement for Neo4j. Yeah, but honestly we use the Cipher to Gremlin to support Cipher.
Gotcha.
Yeah.
Do you run into any problems with that, or have you run into any problems trying that?
Currently, the performance is very good. I don't see there is an overhead. I'm not sure why, but if it's good enough, then we won't do some native Cypher support, since currently we compare with the Neo4j performance for some user requirement. The user already have Cypher query, and they just use our current design, and it's faster than Neo4j.
Oh, interesting.
So, yeah, I think the Cypher 2 Gremlin product is the product is pretty robust, and
that's interesting. I mean, I think it's, I don't know. I think we've seen where, at least I've seen where it doesn't always generate like the nicest.
Yeah. Sometimes we do some improvement on that. Sometimes the Gremlin is generated cannot get a very good performance. For that, we are do some modification and improvement. After we have some concrete result, we are trying to contribute back to the project.
Another question came up, and this was actually earlier, and I forgot to bring it up while you were talking earlier. So you mentioned earlier that your benchmarks were using Iceberg as a data source. Have you found that some data sources better suited for different workloads?
I think for the large data set, we recommend the data lake solution, since first, the data lake solution is the open format, so we can directly scan the data instead of issue some small SQL query into the data source. So we can get rid of the JDBC things. And we have a close relation with Tabular guys. The co-founders are working with the demo, and also will put our engine into their official engine store. And so currently what we are recommending is, you can also, there are a lot of articles compare different lakehouse and different and compare data warehouse and data lakehouse. And I think sometimes is the pros and cons are also valid for us as well. So, for example, Hudi have some advantage, and Iceberg have some advantage, and also there will be time traveling features and some other transactional features that's also valid for us, since our ideal case, we want the user use us just as a read-only engine and write result back to the data lake. In this case, the streaming to data lake things and the insert and updating for the data lakes is actually independent than our product. We just leverage it, but whether the streaming is good or not, and whether the transactional insert and update are good or not are based on the data lake itself.
Gotcha.
So we are trying to take advantage of all the existing product instead of reinvent the wheels.
Right. Okay, good. Let me see. Another question I had was, so I think you'd mentioned you were working on, you have 3.6 working for TinkerPop, and you're working towards 3.7 and getting all the tests running. Are there any Gremlin steps that currently aren't supported by PuppyGraph, or is the entire language and syntax available for folks?
We're trying to be 100 compatible, but since there is a lot, so we still have some feature gaps, I think.
Okay.
Yeah.
I mean, I assume like adding vertices, like write type steps, is that something that you all allow in any way?
We allow it, but we don't recommend that. So first, actually, we make it since Gremlin can be schemaless, but that in our case we have to be have a schema before we run the query. So when user want to add or at nodes or at edge, if cannot match the schema, we just reject it.
Yeah.
And if match the schema, we'll allow to do it. But we don't recommend the user to do that, since we want the user, if, for example, if your data are already in PostgreSQL, we definitely want to use a single writer for the PostgreSQL. We don't want the user to use SQL to write the data and at the same time use our engine to write the data.
Right.
Then it's hard to maintain. And for example, maybe the SQL side user will, where the data is from. So I didn't do anything about that, and there is no SQL script. But
Right.
then there are data keeping coming from the PuppyGraph side.
Right.
It's kind of hard to maintain. So we want the user have a single source to write the data.
I suppose there's still use cases for writing, though, with in terms of I don't know, doing some sort of analysis on the data and writing back some properties to include some weight on an edge or something along those lines, right? Okay.
Yeah, that works. And but if you want to add a new node, we recommend the user to use the insert.
Gotcha.
Of SQL.
Yeah. Is there anything that keeps these things? Are these in sync while that's happening, or is this like a kind of a? You just mentioned, like, I don't know, if somebody does an insert into Postgres, does that sort of somehow immediately become available back in the graph, or is that?
Yeah, we have a cache switch, and then you can turn it off or turn it on. If it's off, we always query the latest version.
Oh, wow. Sick. Can you say much about like how much of TinkerPop you rely on and what components you actually use? I mean, do you have your own query engine, or are you relying mostly on like the, TinkerPop's, step execution and all that kind of thing?
First, we leverage all the syntax of Gremlin, and also we use Gremlin server and Gremlin client, and most of the framework are used by us. And only when there is a heavy evaluation, and then since the Java is not good at vectorized evaluation or some other kind of thing, and so we have what we are doing is that the execution engine is written in C++, and then this part can be also distributed and shuffle between different compute nodes.
Okay, so it sounds like you have a kind of a relatively standard kind of TinkerPop implementation where you're replacing, kind of using strategies to replace steps in Gremlin, or are you like parsing Gremlin with the ANTLR grammar explicitly and kind of building up your logical plan of the query that way?
We have steps. We use the steps, but
okay.
For steps, we will call the C++ we run.
Yeah. Okay. Yeah, that's what I'm getting at. Okay. Interesting. Very good.
By the way, sometimes if steps between steps and steps, if there will be a computation in JVM, we will have a judgment before whether it's a heavy, is a big data evaluation or it's just some control signal. If a control signal, we will put it, we keep it in JVM. But if super large data set, we won't pull it from the C++ side into JVM, since then it will talk with the talk between JVM and the C++ side will be very time consuming.
Yes.
But sometimes it still will be, since we haven't make all this into C++. Sometimes,
right.
Yeah. But this, if you guys miss this kind of issue, some query is slow, please let us know. We will definitely fix it to make faster instead of transfer data between the JVM and the C++ side.
Right. I mean, I think I mean, that's kind of one of the tricks with Gremlin is getting the optimization right as a provider. You know, it isn't always easy to detect exactly what the query is doing, and there's a lot of ways to ask for the same data in different ways with Gremlin, and that traditionally ends up being a problem for a lot of people who implement it. So I think as you gather more users and use cases and people writing different kinds of Gremlin, you'll probably run into kind of those kinds of things to look out for. I only had a couple other questions. We'll see if any other things kind of land in the chat. But could you say just maybe what folks are liking most about PuppyGraph? Like, what are you hearing as the thing that people are really, really liking about it?
I think it's a quick POC. Since we also collaborate with some companies' graph database team, since they want to promote the graph database to their user, but the user want to see the benefits before the investment. But if they use the graph database, they need to a lot of pre-work, like loading the data into the graph database and then try some query. But with us, they can first run some Gremlin query and get some result. And the user, oh, this is much easier than the super long SQL script or some Spark workload. Yeah. And then they can write a report to their leadership and say that, oh, this is how the Gremlin is better than the SQL, and also the complex query can generate some meaningful result. After that, they can use the graph database to do the online service or something else. Of course, they can just use us as well, if they have some tuning and configuration, like how many data they will cache and indexing. Yeah. And so the quick POC is also because usually when user design a graph schema, it's easy to change their mind. When I was at TigerGraph, we do some schema change statement and features, but still super complicated. And actually it rewrites data internally. If also there are some user load data, and after the schema is not they want, they need to design a new schema and load data again, which is very time consuming, especially sometimes the data load fails. But with us, they can write a new schema and run the new query. And if it doesn't, it's not what they want, they can just write a new JSON file and for the new schema and run the new query based on the new version of the schema. It's usually happened in less than 1 minute, so save a lot of their time. So the POC will be much faster. Yeah, that's about what I estimated. I tell you, that is that initial. The easier you can make that process of getting someone's data, into the graph, the easier it is to get that, get that confidence that, taking the graph route is, is the right way. And typically the biggest problem with getting started with graphs is a lot of times that first step of loading data and converting it into a graph. And if you found a way to simplify that with a few steps, that's a huge deal. Last question I have, there's a number of, I'm pretty sure there's a number of TinkerPop contributors paying attention. So I give you a chance to talk to them directly. What kind of help, would you like to see from TinkerPop? What things would make, PuppyGraph easier to use, easier to implement, easier to test? Is there anything that you've come across that would be helpful? Whether we can have a large set of compliance tests, and then it will be easier for us if we pass all the tests, which means we support all the features.
Okay.
And then when I was at Google, there is something. I was in a team. The team currently independent from Google F1 is called Google SQL. And then there is a bunch of compliance tests, and all the internal team who like Spanner, BigQuery, since all of them support Google SQL, and all of them contribute a new feature into the library. And each time when they contribute new feature, they also contribute a test case into it. And so different products can support a subset of the query, the syntax. But they already have all the test case. You can just run it, the entire data test, the set of test cases, and then you will realize, oh, this feature I missed, or this feature I missed.
Yeah, I mean we have something like that. We have that now in a sense, right? With the Gremlin test suite. Is there something more you'd want to see with that? For me, I think the area it's maybe lacking is in testing, sort of. In testing, I think one of the areas we're missing is matrix testing over multiple language variants and things like that. But is there something more you'd like to see in the test suite beyond sort of the language agnostic test suite that's there now?
I think sometimes even we passed the case, and for example, sometimes there is a serializer problem, and there are also different. It seems that different graph databases supporting TinkerTop have a different version. Like seems Janus Graph and Amazon Neptune sometimes are different, and the compatibility make us struggle at the beginning. But then we figure out what happened, and then currently, I think it works. But for the beginners, maybe like what's expected for Janus Graph, what's expected for Amazon Neptune, and we can have maybe some labels there and see where is the difference.
Okay, well, cool.
Yeah, we think the TinkerTop is a super good project and very flexible, and almost have all the necessary parts, and we can choose which one we will use and which one we want to have our own component to replace that part. So the experience is pretty good. So I think that's why most of the IT companies who are created their own graph in-house graph database are actually adopting TinkerTop framework.
Yeah.
Since I know a lot of that, like the eBay, the PayPal, Baidu, Huawei, and the different company all over the world. Yeah.
Well, yeah, I'm glad you all really like Gremlin and TinkerPop over there at PuppyGraph. Definitely appreciate you coming on here. Was there anything else you wanted to say before we kind of sign off here?
Well, if you guys meet any bug, please let us know. We will fix it quickly. Yeah.
Okay. Sounds good. All right. Well, thank you everybody for joining today, and thanks for the great questions. And thanks to Wemo for being here and talking about PuppyGraph. We'll see you at the next TinkerPop Wide session. Take care.
Yeah. Thank you so much.
All right. Bye.